So we need to be able to find the critical values for the chi-square distribution. And we can do this a lot of ways, just like with the t-distribution or the normal distribution. We can use technology, we can use Excel, StatCrunch. Calculators don't do this, but on the exams, as with the t-distribution, I will give you the table. As a matter of fact, let me bring it up right here. Hold on one sec. Right here. Oh, you might be wondering, hey, where does that come from again? It's let me just show you. It's under Tools for Success. So over here, Tools for Success, there's a lot of good stuff in there actually, but it's the formula table card right here. Formula table card. So you click on that, and there it is. And actually, while you're making your note sheets for your exams, this is a good place to start for at least just the formulas that should, probably be on your note sheet. But at the back end are tables, and I will just give you these 4 tables. I'll give them to every student. Nobody needs to memorize this or put this on a note sheet or anything. Okay, so let's see, right here. Oh, and just in case you want to notice quickly, there's a small quick reference right here for some of the z-scores for confidence level. And then remember at the bottom row, there's some quick reference right there for the z-scores. And then we used the t distribution last time, and then this last one right here is the chi-square. Okay, now we're restricted because we're restricted to only the values that they have in this table, which might not be good for us. But on your exams, of course, if I ask you for a critical value, it'll be something that's out of this table. But for other problems, maybe it won't be, I don't know, in a project or on a technology assignment or something like that. Speaking of which, let's go find some. Okay, so let me go back to the notes right here. I just put a little screen capture of part of that table in there for you. But you can see from the chi-square distribution that the center will be your percentage, your confidence level, and then you'll have alpha over 2 over here and alpha over 2 over here, and they're not symmetric, so don't expect them to be the same number. And remember, the far edge of this is 0, so both of these numbers are going to be positive, as in the whole table is positive. So we're going to find the critical 1 minus alpha over 2 and alpha over 2 chi-square values. Again, it looks like an X, I know, but it's not. It's a Greek letter. It's the Greek letter chi. So when you see it, it's kind of a swirly X. That's chi-square. Or if you want to just write CHI, chi, that's fine. All right, so a 95% confidence and a sample size of n equals 18. Now, I'm going to do this a couple ways. I'm going to do it from the table, and then I'm going to go do it with technology as well. But before we even get into any of that, we kind of need to do a little background here. If it's 95% confidence, that means that alpha is equal to 0.05, right? Right. Okay, so if alpha is equal to 0.05, then what's alpha over 2? That'll be better. That would be 0.05 divided by 2, which is 0.025, which is one we've seen a lot before. It's not the only one we work with, but dang, does 95% show up a lot. It's because it shows up a lot in the news and media and science and stuff like that. Okay, so what's 1 minus alpha over 2? Because in case you missed it, that was the other one. So here, I'll show it to you right there. See, these are the 2 critical values. That's what the picture up top says. One is alpha over 2, one is 1 minus alpha over 2. Because remember that little number, alpha over 2, is the area to the right of you. That's a notation we've seen before. So this little guy over here is alpha over 2, and then so what's all of this? Well, this is alpha over 2 over here on the left, so the gray and the blue together over here makes 1 minus alpha over 2, because just like any probability distribution, it's got to have 1 for the whole thing. So the area of the entire thing is 1, so the area to the right of this left-hand one over here is 1 minus alpha over 2, which would be what? It'd be 1 minus 0.025, which is 0.975. They've got to add up to 1. That's kind of a cue. So if you get this one to be 0.025, then this one over here has to be 1 minus that, right? They've got to add up to 1. Okay, so we got those 2 things. So we kind of set that up. Now, why am I doing that? Why am I bothering? Well, because that gives us what column we're going to look at. We're going to look at the 0.975 column, this one right here, and we're going to look at the 0.025 column. Now, the other thing we need to keep in mind is that if n is equal to 1, or excuse me, n is equal to 18, our degrees of freedom, df, is equal to n minus 1, which is equal to 18 minus 1, which is equal to 17. Okay, so this gives you, hold on, the row you're going to look at in the table. And down here gives you the columns, both of them, because there's two of them. In the t-table, we didn't need to bother with two of them. We just got one and it was fine. Here, let me go back to the t-table. So if you look at the t-table, and actually the normal table works this way too, but when you look at the t-table, there's no 0.975s in this. It's 0.25, 0.20, and so on. And every number in here is positive. Well, that's because it's symmetric around 0. So if you have one half of this thing, you have the other half, because, you know, one's positive 1, one's negative 1, one's positive 1.9, one's negative 1.9. The chi-square does not work that way because it's not symmetric. So you have to have 0.025 and 0.975 to get you the right hand and the left hand. Oops, my phone's ringing. Hold on. Sorry about that. All right, where was I? Okay, so the chi-square distribution, sorry if I'm repeating myself, has to give you the ones on the left, which are over here. They're the 0.9s and so on. And the ones on the right, which are the 0.1s, 0.05s, and so on. Okay, so we want 0.975, row number, oh, rats, I don't remember. Row number 17. Okay, row number 17. So we want this score right here, which is 7.564. That's the one on the left. And then 0.025, we want this score right here, which is 30.191. And if you want, on your own paper copy of this, you might want to put like a little vertical line down the center right here between the 0.90 and the 0.10, because the whole table is kind of symmetric. It's got, which is kind of ironic considering the chi-square distribution is not symmetric at all, but basically they match up. So 0.90, 0.10 go together, 0.95, 0.05 go together, 0.975, 0.025 go together, and so on. Okay? And then they, just in case you're confused, you can remind yourself what's going on. Down here at the very bottom, they have a picture. We're working with confidence intervals, so we're always using this right-hand one. These other two kind of show up at some later dates, namely chapter 10 and 11 and 12. So we're working with this stuff right here. So the middle is 95%. So this over here is 0.025. This over here is 0.025. That's what they're showing us. Okay, and actually the t-curve also shows you that, just so you know that they're showing you that they've got the area of the right tail. So you can always use those little pictures there to help yourself. Okay, so we got the two numbers. What were they? 7.564 and 30.191. I'm going to write them down. There we go. I typed them up. You, of course, would just be writing along in your notes, but that's what they are. Now, I want to also show you how to find them with Excel and StatCrunch if possible. So let's go to our technology assignment. I'm going to make a new tab, 9.3 example. I think this is example 2. Let me double check that. Yep, example 2. Okay. Okay, so I'm going to find these with Excel first. I don't know why, I just feel like it. Okay, so remember that alpha was equal to 0.05. No, you don't have to do this. I'm just trying to organize our lives here so we don't forget. 0.025. So 1 minus alpha over 2 is equal to 1 minus that value, which is 0.975. Okay, when we want the chi distribution, so we want, oh, I can never remember how to do both of these. All right, so we'll go to chi square number 1. All right, so equals chi. Now we have a lot of choices here. It gets kind of crazy. So we have the chi inverse, or the chi inverse RT, chi square dot inverse, chi square dot inverse dot RT, or we have this chi inverse right here. Okay, so that's old school Excel from Excel 2007 and earlier. All right, so let's do this one. You can see over here it says returns the inverse of the left-tailed probability. See that? Left-tailed probability. So it's doing the opposite of what the table does. The table does the right-tailed probability. This chi-square inverse business is going to do the left-tailed probability. So if I do 0.025, comma, my degrees of freedom was, oh, I didn't put that in there, 17. 7.564, just like the table did. Okay, so this was the left-hand one. I better make a note, left hand. Or if you like, you can say this was the chi-square. The left-hand one is the one that's the 1 minus alpha over 2. 1 minus alpha over 2. And yes, you could use the insert symbol if you want to be crafty. Instead of doing alpha, you can do insert symbol alpha. Aren't I tricky? All right. All right, so if you feel like doing it, you can do it again. There. All right, so now what about the other chi-square? So I need the chi-square for just alpha over 2. Now we can do this a couple ways, but I think it might be easy if we just use the same distribution. So chi sq dot, sq.inv, that's the one we want. And then you want 0.975 comma 17. There you go. Got it. Now with new Excel, you have another option as well. Let me just show it to you. It's the other chi-square inverse one, this one. The one that's .rt, right tail, get it, right tail. So you could do 0.025 comma 17. There we go, that's the right tailed one. And then you could do it again. Oops. But with 0.975. There you go. And that actually matches better with the table. So if you're more comfortable with that one, fine, whatever. So chi-square inverse does left tail like most functions. Chi-square RT does right tail just like the table does. So if you're more comfortable with that one, use that one. Use whichever one of those two you like. It's fine. Now, what about chi-square inverse, the old school? So if you're stuck with old school Excel, it's a little bit harder. That's the chi inverse. There's 2 I's in there, chi inverse. Hold on. Chi inverse. So I wanted to kind of have my mouse kind of hover down here. There it is. So it's blah, blah, blah. It returns the inverse, now read this, of the right-tailed probability of the chi-square distribution. See that? So it is automatically a right tail. Sorry about that. That time was my husband. Okay, so I pick chi inverse. Again, it says the right tail. So that means it's going to work like that. The one with the .rt, that's how this is going to work. So if I take 0.025 comma 17, there, that gives you the right-hand one, 30.19, bigger than this one. And then if you did the other one, it'd be chi inverse 0.025 comma 17. So if you're, oh, sorry, I did it wrong, 975, sorry, 975. There we go. So that, you can see it, you can get it with the old school function or the new school functions, whichever. I kind of like the new school ones because I like the denotation to myself that, oh, this is right tail. Or when it doesn't have it, oh, it's left tail. I mean, all the other functions work with left tail, so I don't know why they had chi inverse not doing that, but what do I know? Of course, the T one was really messed up with the double tail thing. All right, so we've got those with Excel. You can see the values right there. Aren't they lovely? Now, what about StatCrunch? To StatCrunch, find them as well. Let's see. So, oops, I still have that up. That's no big deal. So I go to Stat, Calculators, chi-square. See right there? And it's going to say, what do you want? And I'll do a right-tailed one. My degrees of freedom was 17. And I go 0.025. Compute. There it is, 30.191. Thing of beauty. I'm going to take a picture of it. This is 9.3 example 2A. Or 2, yeah, I'll call it 2A. And then I'll do it again immediately, 975. Compute. And there's the other one, 7.56. Or if you like, you can make it a left tail, type 0.025, click compute. That would also find it. So, and then I'm going to save it, and I'm going to copy and paste these pictures in. Example 2B into my Excel spreadsheet for part of my technology assignment. Those will be under my results. Meh. All right, I'm going to copy and paste these. I'll be right back. It's the old copy thing. All right, I copied the second one, and then I'm going to paste it in here. And there you go. So now I've proven it with StatCrunch over here with these pictures and with Excel. And we've learned how to find chi-square values. All right, we will stop right here, and we'll meet up next time for actually making the construction of the confidence interval. See you then.